Hi, I'm Selva Prabhakaran. In this one, let's understand what is the z-score, also called as the standard normal variate. And the process of converting a given random variable into z-scores is called standardization. Let's understand these concepts very clearly in this one. This is something that you will come across throughout statistics. Alright, as usual, let's start with an example. Let's imagine you have the marks of students in any given competitive exam. And we know that these marks follows a normal distribution. Alright, and we represent these marks in a general form as xi, which has these values x1, x2, so on and so forth till xn. So you have these values and we represent it to follow a normal distribution of mean mu and variance of sigma square. Alright, so we have this. So now we have this variable. I have expanded it to represent a given column in a data frame. You can think of it like this. Now we want to do the standardization and calculate the z-score for each of these individual values present in this data. How do we do that? So what we want to do is, in order to do the standardization, what we want to do is, we compute the mean of this particular column, of this particular data. That comes out to be x dash. We represent it as x dash. We also compute the standard deviation. We know how to compute both of this. Now, once you have these values, from each of these values, x1, x2, so on and so forth till xn, from each of these values, we subtract the mean and divide by the standard deviation. So here x1, so to get x1 dash, to get x1 dash, we subtract the mean x bar and divide the whole thing by sigma. That computed, that transformed value here we are representing it as x1 dash. This is nothing but the z-score, corresponding to x1 here, we have here. Likewise, we do the same for x2. Do the same transformation from x2, we subtract the mean and divide by the standard deviation. Alright, we do this for all of these individual values in the original data and we get corresponding values of x1 dash, x2 dash, so on and so forth till xn dash. All of these values represent what is called as the z-score. This is how we compute the z-score, as simple as that. Alright, and this process of converting this original variable to z-score is what we call as standardization. This is very common term, very often used in machine learning as such. Now comes the question, why do we even care about standardizing the data? Why standardize the data in the first place? One major advantage is once you know the z-score of a given variable, okay, so you have a given value, say x1, let's say you have a given value, we compute the z-score of that value. Once this is known, we know exactly how far is that value. Suppose we have the mean here. For a standardized data, the mean is going to be always equal to 0 and the standard deviation is always going to be equal to 1. Alright, for the standardized data. Now, if you draw a normal distribution around this, the mean at the center here is going to be 0 always. And if we know the z-score, suppose the z-score value is going to be equal to 1, let's say, that value is going to be present here. Now, instantly by knowing what the z-score is, we know how far is this value away from the mean. This is very useful. Why? Because if this z-score is too large, let's say this is 3 plus, the z-score is 3 plus, that means that particular value is 3 standard deviations away from the mean. So it is some value that is present over here, somewhere over here in this region, which means this is a rare occurrence to happen for that particular distribution, which also means that this particular observation could very well be an outlier. So being able to detect outliers is one reason. Being able to detect outliers is one reason. Another reason is it brings all the variables in a given data set to the same scale. What this means is, suppose you have a data set. Suppose you have the age as say 20, 80, 65, so on and so forth values. And you have another column in the data set that contains the salary values. Now, salary is going to be a very large number. Say this is 100K, 250K, 50K, so on and so forth. So we have different values. Now, age typically varies between say 0 to or maybe 1 to 100, let's say. Whereas salary would range anywhere between 0 to 1 million or even more, isn't it? These two variables are on different scales. If you do standardization of both of these variables, the mean of both of these variables is going to come back to 0, alright? And standard deviation is going to be 1. After standardization, you compute z-scores for both age as well as salary. By converting this into z-scores, we will be able to retain the information, the variance, the information. So this value 80 here is much larger than the value 20. right? And 65 is greater than 20 but lesser than 80. If you convert these values into z-scores, right, the relationships, the ranking of these values, say this is z-score 1, z-score 2, z-score 3, we convert it into these z-scores. Z1 will always be lower than Z2 and Z3. The same ranking it follows in the original data. Likewise, Z2 will be greater than Z1 as well as Z3. And Z3 will always be greater than Z1 but lesser than Z2. So that ranking or the ordering will be maintained, right? That is, the information present in the data is retained when you are converting it into Z-scores. But the mean and the standard deviation will always be equal to 0 and 1, which is beneficial whenever you are going to build machine learning models using standardized data. That's also a very important reason for you to know about what standardization is all about and why we even need to do standardization on any given random variable.